Hi, my name is Natividad Perez, and I will be teaching guys implicit differentiation. The definition of this topic is that it makes use of the chain rule to differentiate a function which cannot be explicitly expressed in the form of y equals f of x. How do we use implicit differentiation in math? We use it to help us find the derivative of y by using the chain rule or sometimes the product rule. It also allows us to find y prime, not x prime, in scenarios where we can't separate the function. Well, who discovered implicit differentiation? Well, implicit differentiation was developed by the famed mathematician and physicist Isaac Newton. He applied it to various physics problems he came across, as well as the German mathematician Gottfried W. Now let's begin with our first example. We have to keep in mind that when finding y prime, we also have to find the derivative of every number within the function, meaning that we could use quotient rule, product rule, or even chain rule, so anything could come into use. Now let's write our first example down. So it's going to be x to the power 3 plus squared y plus 4y squared equals 6. Okay, so we're just going to find the derivative of each number, and to find it, we're going to have to use the power rule. Except for this one, so I'm just going to delete that. Except for the middle one, because the middle one is a little bit more complicated. I'm just going to get into it a little bit later. So for the power rule, I'm just going to put the exponent in front, and I'm going to minus it by 1. So this is going to be 3x squared. I'm just going to leave this alone. So I'm going to leave an empty blank. I'm going to put 8y. And also, when there's a y included into this where we're trying to find y prime, there's always going to be a y prime because there's no x to divide it by x. Since basically we're trying to find d over dx, so there's no x, so there's nothing to divide it with, so it's going to be y prime. And then for 6, kind of the same thing applies, but since it's a whole number and there's no x, it's just going to be 0. So that's going to be it. And then I'm just going to put this to the side, and I'm just going to solve it using I'm just going to be using the product rule now, which is f times g plus g derivative of f. So that's going to be, this is the product rule. So I'm going to be using that for this. So I'm just going to be separating these two variables into two different functions. So this is going to be f, and this is going to be g. So first, let's find the derivative of f, which is going to be 2x. And then we're going to find the derivative of g, which is going to be just y prime. And now we're just going to continue with plugging in these variables into this formula. So I'm just going to put f prime, which is 2x, times g, which is just going to be y, plus g, the derivative of g, which is going to be y prime, times f, which is just x squared. So that's going to multiply this and this. It's going to be 2xy plus y prime x squared. And that's what we get. However, I'm just going to switch this up real quick, just not to get confused. So I'm just going to put this in the front and then y prime. And that's what we get. This is going to be the derivative of this. So now that we've done that, I'm just going to erase it. So I'm just going to copy what I did. I'm just going to put it down. I'm going to put some more space because I think I wrote it too close. Plus 8 prime equals 0. Just going to leave it like that. Okay, now we're just going to simplify the whole function. So I could tell that these two numbers don't have y prime in them. So I'm just going to subtract this and move it to the other side. Okay, so I'm just going to erase that. And then I'm going to move this over here. Okay, that's what we got. And now since we're trying to find y prime, I'm just going to factor y prime out of both little. I'm just going to put x squared. Since we're taking this out, I'm just going to put this in here. And so we're taking out this. I'm just going to put plus 8y equals minus negative 2, 3 squared. Okay, and I'm going to divide it by this. Sorry. Okay, and then this is our y prime. This is our answer. And that's how you solve using implicit differentiation. Let's try a question that involves trig functions. Okay, so for this one, I'm just going to name it 2. I'm going to write down the problem, which is now you notice that this specific problem involves like 4 different problems within a problem. So in this case, we're going to use product rule. Basically the same thing that we used last time. But first, we're just going to do it at the beginning. So we're going to put x squared. So basically from the last time, I'm just going to use this. And then I'm going to find the y prime, which is going to be 2x. And I'm just going to leave the f alone. And then I'm just going to do the same thing for the y prime. So I'm just going to put 2y, y prime. And then I'm going to work on the other side. Plus x cos y, y prime. Okay, I'm just going to erase this because this is kind of in my way. And then I'm going to put plus sin y times 1 equals 0. Okay, so you might be asking, how did I get cos y? Well, the derivative of sin y is cos y. So that's why I put cos y. And you might be asking, how did I get 1? Well, in this case, I was going to find a derivative of x, but there was no power, so I just had to divide it by x, so that equals 1. So I'm just going to move on to the next step. And then from here, do the same step that I did here. Just going to combine them. Okay, so this is kind of useless because it's going to be sin y, so I'm just going to erase this. 0. Okay, and then I'm going to move all the numbers that don't have y prime in them to the other side. So I'm just going to subtract this. Oh shoot, I made a mistake. I'm not going to remove this one. I'm just going to remove minus sin y. Okay, and I'm just going to remove these two. So this is going to be 2 plus... Okay, now, so I'm just gonna factor the y prime outside. So I'm just gonna do this. And then I'm gonna put the 2y. And then plus x cos y. And I'm just gonna copy the same thing I had. And then I'm gonna divide this with the other function. And cross it out. And this is my answer. I get y prime equals negative 2xy squared minus sin y divided by 2y plus x cos y. And that's our answer. After teaching implicit differentiation, I believe that it is a topic that is kind of middle ground, because you just have to get used to the fact that you have to use different methods in order to find the derivative of each number using chain rule, product rule, and power rule. You just have to get used to that in order for it to become a short process. But I find it a little bit relevant because it can help you practice finding derivatives